So welcome back. This time we're going to be taking a look at line notation for a cell. And when it comes to line notation, a couple things we need to think about. As you've seen in some of the drawings, if you've been looking at some of the galvanic cell drawings, we're typically going to divide things anode, cathode. And to show that division, we're going to have two vertical lines. And so when we look at an example problem like this, what is the standard cell potential for the reaction shown below, and also write the line notation for the cell, the way that we can work this one out is, first of all, we need to establish what's going to be going on here. So we know that we've got Cr goes to Cr3+, and if this were the half reaction, we'd also have to account for the electrons, so we don't want to forget those electrons. And so we've got chromium doing that, and so that should be potentially a value of positive 0.74, depending on where you're getting your values from. There is a bit of disagreement at times between reference materials in terms of the voltages. And the other one that we're going to have here, now it looks like we've got this one oriented as tetrachloro gold 3. So we've got this going to be solid gold plus 4Cl minus, and in this case we should have 3 electrons over here. And the standard cell potential for this one is going to be, according to the reference material that I have, 0.99. So I will say that I have blended reference sources here to get my result. And when I add everything up, looks like we're going to be at something around like, what, 1.73 volts for the cell. So, not sure what just happened there. Okay, so we've dealt with standard cell potential for the reaction. Just deal with that. The substances, as shown, have to be where they are. So chromium had to be a reactant. You know, the tetrachloro gold 3 had to be a reactant as well. And our products had to be products when we were writing out our half reaction. So that basically gave us the orientation for things. So what this means now is we need to figure out what's going to be in the anode and what's going to be in the cathode. Now, in some of the videos that I've done, I've had the reduction half reaction on top and the oxidation half reaction on the bottom. Well, it just so happens that this time I've got my oxidation half reaction on top and reduction half reaction on bottom. The reason that this is noteworthy is because it's the oxidation half reaction that actually is going to give us our anode components. And it's the reduction half reaction that's going to give us our cathode compartments. So again, two vertical lines to separate the anode and the cathode. And then what we're going to use is single lines to separate substances that are in different phases. So when it comes to what we're actually going to be taking a look at as far as line notation for the oxidation half reaction, we're going to be focused on these two substances. Because really, the electrons are the commodity. That's what's basically jumping over this double line. So we don't really worry about including that in our line notation. So when it comes to this, we need to remember that we have two substances, both the same element but different forms of the element, which means we're going to need to separate them with a solid, a single line, single vertical line. So essentially what we're saying is phase 1, phase 2, and if there were other phases present in the half reactions, then I could go on to 3 and 4, and pretty much that's about where you're going to run out. Because if you consider solid, liquid, gas, and then aqueous, that's about all you got. My recommendation is always to put the solids on the outsides of our line notation, so at the very outsides. So for this case, we'll put chromium solid here on the outside. That's what's going to behave as the electrode for our anode compartment. And then the other component of our anode compartment is going to be Cr3+. So it's kind of like we've taken chromium 3+, and turned it into this side of our line notation. So now we have to deal with the cathode portion. So we've got anode in line notation. The anode will be listed on the left, and the cathode will be listed on the right. Because we don't normally write down anode or phase 1 or phase 2, I'm not going to write down phase 1, phase 2, but when I look here, I see that I've got ion and ion. So those two are both going to be aqueous and in the same phase. So when I think about this line notation, I notice that I'm going to have a solid and then two ions. So what this does for me is it tells me that I'm going to want to I'm going to have to split them up. So now it's a matter of what do I put where. And as I said earlier, I like to put my solids on the outside. So solid gold will be over here. And so this starts again to give us the basis for a galvanic cell. And so all I need to do now is figure out what's going to be in solution, and that's what I'm going to put here, the aqueous, so the other phase. And so it looks like I'm going to have two pieces that are present here. I'm going to have, again, that tetrachlorogold 3 ion, but I'm also going to have a chloride set of ions. And so this is how that works. I separate substances that are in the same phase with a comma. If substances are in different phases, then I separate them with a single solid line. Substances that are part of the two different compartments, anode and cathode, I separate with two solid lines. And so up here now, I can put AlCl4- and Cl-. So, looks like I've now turned, or could have turned, a galvanic cell sketch into line notation, or through this line notation, somebody would be able to interpret it to understand that this is the galvanic cell that is, in essence, being formed. So I hope this clears up line notation for you. It certainly is possible that you would have more than two phases. Solid, aqueous, and then possibly gas phase can occur. You could have solid, aqueous, and liquid, solid, gas, and liquid. Possible that it's just going to be aqueous and gas, but you're always going to have a solid. So let's say, for example, that you were using a half reaction such as O2 plus 2H2O plus 4 electrons yields 4OH minus. So we would have aqueous, liquid, let's say, and gas. So depending on what side we were putting this half reaction on, let's say that we put it on the, let's see if I can make some room for this information here. So there we go. Let's just do this. So let's say that I'm going to put it on the cathode compartment side. If you look here, in this half reaction there are no solids present, which means that I'm going to have to provide an electrode that's not going to be a part of this half reaction. You may recall me recommending that we make platinum that electrode. So for this cathode compartment, it would be platinum. That would be the electrode. And then in solution would be hydroxide, water, and the oxygen gas. So with that being said, how are we going to write this up? So I've got oxygen, which is gas phase. I've got water, which is liquid phase. I've got hydroxide, which is aqueous. And then I have my electrode. Now again, platinum was not part of the half reaction, but it is still going to be listed in the line notation because it is a part of the cathode compartment. And so we're going to put this, given my preference, on the outside. For the anode, you'd have something else there, whatever it might be, in order to make this work out. Could possibly have something like manganese solid with manganese ions to make things real quick and nice and neat. And so then we would have had Mn solid goes to Mn2 plus and 2 electrons. And then this would have had to be doubled so that when we put everything together it would have all worked out. So I hope that this clears up line notation in terms of what to do when you don't have a solid. I recommend platinum as your electrode. And then what to do in terms of going back and forth between a sketch and line notation. So good luck putting it to use for yourselves.